Mars can be secretly messing up the depths of our oceans. The red planet is 225 million kilometers away from Earth, so we once thought that it couldn't have much of an impact on us. But that changed recently with the discovery of some kind of butterfly effect. What starts with a small gravitational pull in space ends up creating giant whirlpools down here. This suspicion began when scientists decided to explore almost 300 deep holes drilled in the ocean floor, which were made back in the 60s. Their goal was to understand the strength of deep ocean currents by analyzing sediments. I mean, materials like sand or mud that accumulated at the bottom of the ocean over the last 65 million years. The bottom of the ocean has layers upon layers of sediments. When these layers show a continuous pattern, it means that the materials have been gradually layering over time without any sudden interruptions. In other words, deep currents were calm and stable. But the researchers also noticed a strange pattern. During specific time periods, they couldn't find any records of sedimentation, which means that something else was interrupting this process. The most likely reason for these gaps was the presence of intense currents at the bottom of the sea. Because they were so strong, they probably moved sediments from their original spots. But here's the weird part. All the gaps identified in the study occurred at intervals of exactly 2.4 million years. The data showed a total of 27 gaps. That can't just be a coincidence. So the scientists realized they were not checking simple breaks in the sedimentation process. They were analyzing the presence of cycles. According to experts, the only plausible explanation for them lies in space and is probably the result of something known as the astronomical grand cycles. To understand this process, we first need to mention the Milankovitch. They are named after the Serbian scientist who suggested a century ago that changes in the way Earth moves around the sun and tilts on its axis can affect Earth's long-term climate. The thing is, the movements of Earth can be affected by many things, including other planets. Normally, our planet's orbit around the sun isn't a perfect circle, but it is pretty close. However, from time to time, this path is directly affected by the gravitational pull of Jupiter and Saturn. It's kind of like these two giant planets can pull our orbit, causing it to become more elliptical. Variations like this can affect the amount and distribution of sunlight, changing the climate here on Earth. According to the Milankovitch theory, Earth's climatic patterns change in cycles of 405,000 years, 100,000 years, 41,000 years, and 23,000 years. And the theory is that these cycles might trigger the beginning and the end of glaciation periods, also known as ice ages. His theories were actually confirmed in the 70s by scientists who were also looking for evidence of these cycles in ocean floor sediments. Recent calculations have shown that, besides the Milankovitch cycles, there are climate changes that follow much slower rhythms. They don't change every tens of thousands of years. Nope. We're talking about periods that stretch out over millions of years. And this is exactly what the astronomical grand cycles that I mentioned earlier are about. We know about such events basically because of evidence based on mathematics and computer modeling. But it is really hard to find any geological proof of the existence of these million-year astrological cycles or any clue of how they affect Earth. That is, until now. Turns out, what scientists found at the bottom of the ocean could be just the proof we needed, and that's because the 2.4 million period lines up exactly with records of interactions between Earth and Mars. As the two planets chart their orbital paths, their gravitational fields interact in a process known as resonance. Yep, exactly like what happens with Jupiter and Saturn. From time to time, the gravitational forces of the red planet pull our orbit a bit closer to the sun, and just like the shorter Milankovitch cycles, this grand cycle also affects our climate. In this case, by increasing the solar radiation that reaches Earth, making our planet warmer. To be honest, experts believe that this amount of extra solar radiation that Mars can somehow give us is not that big of a deal. I mean, it's not going to make our planet so hot that it will make us feel like we're stepping onto the sun. But this slight difference in climate can be enough to change some behaviors on Earth, such as ocean currents. Warmer climates tend to produce more frequent major storms, and that often produces sediment-stirring eddies, also described as giant whirlpools, which can reach the seafloor at the deepest parts of the ocean, known as the abyss. Finding those gaps in the deep ocean sediment record is really impressive because it's probably the strongest evidence we have of the astronomical grand cycles. As I mentioned at the beginning of the video, it is all like the butterfly effect. Every 2.4 million years, Mars's gravitational pull shifts Earth's path around the sun, causing our climate to warm up. And when the planet is warmer, it can lead to the formation of large whirlpools, which end up turning the deep ocean waters upside down. And there's one more thing. The cycles found in the research also line up with already known periods of warmer climate throughout world history, like the famous Paleocene-Eocene thermal maximum. This event took place around 56 million years ago, when Earth warmed by about 8 degrees Celsius. Loads of theories have popped up trying to figure this out, like a glitch in Earth's orbit, or maybe the passage of a comet. But with this new study, it looks like Mars could also be involved in this event. These new findings are pretty convincing and exciting, sure, but scientists still need to do more work to link these possible cycles of climate change with deep-sea currents. I mean, they did a good job of finding an explanation for the sedimentation gaps, but so far, it's just a suggestion. Their success is really important for the whole scientific community, though. After all, knowing when exactly these astronomical grand cycles happen and how they affect Earth can help us a lot, especially to differentiate when climate change happens due to a natural event and when it occurs due to human intervention. Studying these whirlpools can also provide scientists with crucial insight into how climate change affects ocean circulation. So, another reason why this finding is so crucial has to do with the potential collapse of the Atlantic meridional overturning circulation. In short, this is a system of ocean currents that circulates water within the Atlantic Ocean, being responsible for bringing warm water north and cold water south. This is what brings warmth to different parts of the globe, and also carries nutrients necessary to sustain ocean life. However, there are some fears that this system might stop or become too slow anytime soon. If that happens, oxygen-rich surface waters would no longer mix with deeper waters. But the good thing is that this possible link between Mars and Earth gives a positive take on this situation by suggesting that in a warmer world, more intense deep ocean currents may prevent our seas from stagnating. But again, it's just a suggestion. The evidence is still thin. Some skeptical experts like to point out that, although eddies have indeed become more active over the past few decades, satellite observations have shown that their currents aren't always able to reach the sea floor and maintain an effective water circulation. For now, all we know is that it's hard to say who is right. Only the following studies will tell. Recently, scientists have made an astounding discovery that can change the entire course of Mars exploration. Apparently, there are oceans of liquid water on the red planet, so the future looks bright. We could use this water to support future missions, and then even relocate to Mars, since we wouldn't need to worry about where to get this precious liquid, right? Well, there's one big problem. These oceans of liquid water are in Mars, so deep inside that we aren't likely to get there. At least, that's what a new analysis of seismic data collected by the Mars InSight lander claims. Huge reserves of liquid water seem to be the best explanation for some seismic quirks of the red planet. So all this precious water is out of our reach. But we need to find it to solve the puzzle of the aquatic history of our blushing, dusty neighbor. And the first thing we need to do is identify where the water is and how much of it the planet is hiding.
Navigation has confirmed that the parachute has deployed and we are seeing significant deceleration.
Now, our rovers are scurrying about on the surface of the red planet, gathering all the available data on the planet's surface geology. And it's getting increasingly obvious that Mars was once covered with water. Many factors, from Martian terrains to ancient dry lake beds and deltas, suggest that there was a time when the planet was quite soppy. These days, there's still some water on and right below the surface of Mars, but it's in the form of ice and nowhere near what Mars had in the ancient past. To understand how much of it could have been on the red planet billions of years ago, we must know where all this water went. There are two spots where the water could have gone: into space or toward the interior of Mars. Then, it could have been isolated as either liquid reservoirs or ice deposits. Currently, we don't have any way of measuring how much water once leaked away. But now we finally can find out more about the gooey center of the red planet. All thanks to the Mars InSight lander. It isn't operating anymore, but from November 2018 to December 2022, it was listening to the hums and rumbles and monitoring the activity below its feet. The thing is, acoustic waves, generated by seismic activity deep inside the planet, can change according to the composition and density of the material these waves are moving through. And scientists can get a lot of information analyzing the behavior of seismic waves. In this case, they used a model similar to those used to map underground oil fields and aquifers on our home planet. Then, with the help of this model, they analyzed the data gathered by InSight on Mars. They discovered that the best explanation could be that there was a layer of fractured rocks whose cracks were filled with water deep under the surface of the red planet. That layer could be at a depth of 11 to 19 kilometers. That's why it would be extremely tricky for future missions to get to it. And still, the new discovery could help us understand the Martian water cycle. Confirming the existence of a large reservoir of liquid water can help us sneak a peek at what the climate on Mars used to be, or what it could be like one day. And if once Mars had had a lot of water, it could have been habitable in the ancient past and might become habitable in the future. Water is crucial for life as we know it, so underground water reservoirs on the red planet could already be habitable. Maybe while we're talking, tiny microorganisms or even some tentacled creatures are living their lives in the comfort of their underground home. On Earth, super deep mines do host life, and the bottom of the ocean, with its immense, unbelievable pressures, isn't lifeless either. So far, we haven't found any evidence of life on Mars, but for now, it sounds like this place has the potential to sustain life. InSight data have shown that there isn't likely to be a lot of water ice in the upper crust of the planet, at least in the region around the lander. But if it turns out that there is a water-rich layer deeper below the surface and stretching around the entire globe of the planet, then there would be enough water to fill ancient ocean beds, and even more. Mars isn't the only place outside Earth where there is water, or where we might one day find water. Take the good old Moon, for example. On Earth's natural satellite, water can be found all over the surface. But it's not the water you might be imagining. On the Moon, water remains mostly as ice, and it's distributed unevenly. For example, the poles of the Moon are the regions that never receive sunlight. This is the reason they're extremely cold. So, it's no wonder there's a lot of ice there. The ice in these areas is also often mixed with the lunar soil and hiding deep below the surface. Then, there's Enceladus, the 6th largest moon of Saturn. In reality, it's not that large, just 505 kilometers across. In other words, this moon is small enough to fit inside Arizona. Ooh, we should try that. Interestingly, when the Cassini space probe first arrived at Saturn, researchers were expecting Enceladus to be a frozen ball of ice. But what they saw was plumes of icy particles and water vapor erupting from geysers on the moon's surface. It was clear that there was a massive ocean between the moon's rocky core and its icy shell. Then there's Jupiter's moon Europa. Scientists think that this world is one of the most promising places in the solar system when it comes to searching for new life forms. That's because Europa has a huge saltwater ocean as deep as 64 to 161 kilometers. And even though it's under a layer of ice that is likely to be from 16 to 32 kilometers thick, it's still potentially habitable. Astronomers believe that plumes of water might erupt from cracks in the ice shell and release the contents of the moon's ocean into space. The temperature, pressure, and chemistry are very different on Europa, and astronomers aren't sure yet how the ice behaves there. That's the main reason they haven't figured out yet how deep or large the water reservoirs on Europa are and how long they need to refreeze. But out of all the places where we could find water in the universe, the most bizarre is probably open space. In 2011, two teams of astronomers discovered a cloud of water floating freely among stars. It was the largest and farthest reservoir of water ever detected. So, this massive cloud of water vapor surrounds a black hole, but not just any black hole. This one's a quasar located 12 billion light-years away from Earth. The conditions around this quasar must be really special to create such an enormous amount of water. This cloud contains 140 trillion times the volume of all the water on Earth. That's enough to give every person on the planet a whole planet's worth of water 20,000 times over. Sounds wild, doesn't it? But there's something even cooler. Astronomers think this water cloud formed just 1.6 billion years after the universe itself began. This discovery is yet another sign that water has been around all over the universe, even in its early days. But here's the kicker. Until they found this, scientists had never detected water vapor so far back in time. Sure, there's water in our Milky Way galaxy, but most of it's frozen solid in ice. This discovery really pushes the boundaries of what we know about water in the universe. It's the year 2031, and the first human has just set foot on the red surface of Mars. It was a long flight that lasted 172 days. It was a tough journey. There were lots of technical issues. There were some physiological obstacles. Astronauts had to deliver tons of equipment and energy generating and life-supporting systems to the red planet. Those responsible for the mission had to understand how to deal with low-pressure atmosphere and catastrophic sandstorms, how to keep people safe on Mars's surface, and how to bring them back to Earth after their work is done. It does sound like a science fiction story, but soon it's going to be our reality. But the coolest thing? It's not the limit. After exploring Mars, people might set even more ambitious goals, and this is what some of them may look like. The next planet to visit could be Venus, but it would be a challenging task. Venus is also called the morning or evening star, all because it shines so brightly in Earth's sky that it's the first one to appear after sunset and the last one to vanish after sunrise. But in terms of exploration, Venus is very unfriendly to humans. Its atmospheric pressure is about 92 times as great as the pressure on Earth. And the temperatures on its surface, on average, 850 degrees Fahrenheit. Modern technologies wouldn't allow us to build an infrastructure that would allow people to survive on the planet for longer than a couple of minutes. But then, why would we set sail for Venus? Here's a curious thing. At the height of 30 to 40 miles above the surface of the planet, there are the most Earth-like conditions in the entire solar system. The pressure there is almost the same as in the mountains on Earth, and the temperatures range from 70 to 85 degrees Fahrenheit. If the planet's atmosphere was made up of oxygen and not toxic gases, we could live there without any additional equipment. Or we could go to Phobos and Deimos. Those are Mars' moons. It would be the first time humans set foot on the moon of some other planet. Phobos is located a mere 3,700 miles away from the surface of the red planet. It would take no longer than a day to reach it. This potato-shaped piece of rock is quite small, a mere 13 miles across. This is the reason why it has very weak gravity. Deimos is a bit farther away from Mars, about 15,000 miles, but this mini-moon is even smaller than Phobos. It's a bit more than 7 miles across. In other words, Visiting these moons wouldn't be unlike landing on an asteroid, and the greatest challenge astronauts would face would be leaving the surface of Mars. To do it, they would need loads of fuel. So, most likely, the first trips to Phobos and Deimos would be launched from space stations orbiting Mars. We could set an even more ambitious goal and head for Jupiter and its moons. The distance between this gas giant and our home planet is 365 to 600 million miles. This distance can be so different because the planets follow their elliptical orbits around the Sun, getting closer, then farther apart. The minimal distance occurs every 13 months. If people set off on this long journey during this period of time, it would still take them about 2 years to get there. Since Jupiter is mostly gas, on-planet exploration wouldn't be possible. We could probably fly around the largest planet in the solar system and even dive into its atmosphere. But much more interesting for exploration objects would be Jupiter's moons. Let's say Europa. This natural satellite has a water ice crust. It can be from 10 to 15 miles thick. Under this crust, there might be liquid water. The core of the moon might consist of liquid metal inside a rocky shell. Its super thin atmosphere contains some oxygen. Considering all this, it would be a rather comfortable place for people to explore, if not for its temperature.
It doesn't rise above 240 degrees Fahrenheit.
We could visit another Jupiter's moon that is called Ganymede. It's an ice satellite with a very thin atmosphere that contains oxygen, or Callisto. It's the second largest among Jupiter's moons. Its icy crust is about 124 miles thick, and it's very cold on the moon.
Around 220 degrees Fahrenheit.
People could also send an expedition to Saturn and its moons. For example, Titan or Rhea. The gas giant itself is twice as far away from Earth as Jupiter. It means it would take astronauts more than 3 years to get to this planet. But if the spaceship was launched from a space station on Mars, it could reduce the travel time by 25 to 50%. But even if the starting point of this expedition was Earth, with advanced technologies like nuclear thermal propulsion, such a journey could take just a year or even less. Saturn can't be explored directly, so researchers would probably start with its largest moon, Titan. It's also the second largest moon in the solar system. This natural satellite has an atmosphere that mostly consists of nitrogen. The pressure on its surface is twice higher than that on Earth. There are winds and rain on Titan, lakes, and rivers, but those consist of liquid ethane and methane rather than water. It's actually a good thing. We'd have a lot of resources to produce fuel and energy. Rhea is the second largest of Saturn's moons. It's made up mostly of water ice. Its atmosphere is super thin, but it also has some oxygen in it. Actually, all the largest moons of Saturn have only one serious drawback. It's freezing cold there.
On the bright side, they all have plenty of resources to produce energy and other life-sustaining elements, and it would be much easier and faster than the same process on Mars.
But what if we could explore exoplanets? Those are planets that travel outside our solar system. If we managed to get so far away from Earth, maybe we would reach some potentially habitable worlds. It could be Proxima Centauri b. It's the closest to Earth exoplanet, and recently, astronomers have found out that this world might resemble Earth even more than they previously thought. It's only 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun.
Proxima Centauri b is in the middle of the star's habitable zone.
This means that the chances are liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. It means one of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere. It's traveling too close to its star, so the radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. It would take way longer to reach potentially habitable Gliese 832c. This exoplanet is 16 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. Gliese 832c is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this parent star is a red dwarf, it's much cooler and dimmer than the Sun. So, Gliese 832c gets as much light and heat as our planet does. At the same time, it's still unclear if Gliese 832c is similar to Earth. It probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that unfortunately, Gliese 832c is more likely to resemble scorching hot Venus rather than relatively cool Earth.
In April 2023, astronomers found something exciting: a runaway black hole. This thing is moving through the universe at an incredible speed, about 3.5 million miles per hour. It's 4.5 thousand times faster than the speed of sound. They found it accidentally. Researchers noticed that there was some weird straight line in Hubble images. After some digging, they realized there was a moving black hole. As it moves, it compresses the gas on its path, literally creating new stars along its journey. So it's leaving a beautiful, long trail of stars behind it. And when I say long, I mean it. Its tail is 200,000 light-years long, which is like the length of 2 Milky Ways. Turns out one end of this star trail connects to a distant small galaxy. This is probably where the black hole came from. Most likely there were 2 supermassive black holes whirling around each other. And then another galaxy came along with its own supermassive black hole and ejected one of the original ones like a mean kid, which is why it's called Runaway. There might be a 9th planet with the very original name, Planet 9, in our solar system. If it exists, it's probably somewhere far beyond Pluto. Astronomers think so because some rocky objects near Neptune move in a weird way, as if they were influenced by the gravity of a large, unseen planet. Planet 9 might be a gas or ice giant, 7 times the mass of Earth. One of the ideas is that it could have existed in our solar system, but then bumped into something huge and ended up with a crazy long orbit around our Sun. If we actually discover it, it could change our understanding of the solar system. A new telescope is coming soon, equipped with the largest digital camera ever built, and it will start scanning the sky in 2025. Maybe it will finally spot this mysterious planet. Another awesome discovery was made in 2023. The James Webb Space Telescope found over 500 planet-like objects in the Orion Nebula. Some of them are roughly the mass of Jupiter, so they're literally called Jupiter mass binary objects, or jumbos. They just float out there with no stars, and they're not really stars or planets themselves. What's even crazier is that in about 42 pairs of them, the objects are orbiting each other, even though planets aren't supposed to do that. On top of that, such large objects shouldn't form and exist without a star at all. So now, astronomers are trying to explain this. Perhaps jumbos have formed in places where there was enough stuff for big planet-like objects, but not enough for stars? Or maybe all of them were ejected from their star systems for some reason. Who knows? But now we definitely need to study them. The black hole in the center of our galaxy, Sagittarius A star, used to be super weird. Luckily, it didn't run away like that other one, but it was completely crazy in the past. Astronomers found 2 supermassive structures called the Fermi bubbles and Rosetta bubbles. They spanned about half the width of our entire galaxy, and they've been towering over the Milky Way for over 2 million years now. And scientists think that it's our black hole that created them. It seems like when it was at its peak activity, it had a wild, energetic eruption that lasted about 100,000 years. This event probably left these bubbles. In 2023, the James Webb Space Telescope took a striking, super detailed image of the so-called Herbig-Haro objects. These objects are called Herbig-Haro 46/47. They're basically young stars surrounded by beautiful patches of nebulosity. You can see the stars being surrounded by a disk of material that feeds them as they grow for millions of years. They're located at about 1,470 light-years away, but they're actually not our main topic of discussion. What's much more interesting is this weird thing right below them, a space structure that looks like a question mark. What is this thing? No one knows for sure. It has an orange-red color, which hints that it might be super distant, far from our galaxy, maybe even billions of light-years away. Some think that this strange question mark is probably the result of 2 or more galaxies merging together. One of them was a bit curved, so it's probably a distorted spiral galaxy. The curve might be the tails being stripped off as they spiral towards each other. The other one was rounder and smaller, like a regular spherical one. The gravity games never fail to amaze us. Astronomers started searching for extraterrestrial megastructures. They think that if there's another intelligent civilization out there, they could have built something incredibly huge to power their technology. For example, like Dyson spheres, hypothetical structures around stars that use the star's energy as fuel. Astronomers analyzed some historical telescope data that detects infrared signals. They spotted some weird signals that could hint at the presence of these structures. In total, there are 7 such candidates right now. All of them are coming from red dwarf stars, which are redder, smaller, and less massive than the Sun. Another research institute found 53 potential candidates. They're still not sure what exactly causes these signals, but it could be not Dyson spheres, but some huge debris. It looks like there are some mysterious structures in the center of our galaxy. In 2023, the James Webb Space Telescope has taken a detailed picture of the Sagittarius C region. It's right near the center of the Milky Way. This image showed a dense area where stars are forming. There were many young stars and dark clouds that blocked the light from the stars behind them. That's a very packed place, with about 500,000 stars of different ages, sizes, and colors. This place is very chaotic and extreme. Now, scientists are using it to study star formation. But the weird part is that they noticed something else, the large region of ionized hydrogen. It looks like cyan in the image. This area is about 25 light-years long, surrounding the lower side of dense cloud. And it looks like there are some needle-like structures. They seem to be located randomly, and astronomers have no idea what they are. So now they have to study this in more detail. Astronomers have found a super rare, massive galaxy. It's called JWST 7329, and it's absolutely ancient. Our entire universe is about 13.8 billion years old, but the stars in this galaxy seem to have formed around 13 billion years ago, so just around 800 million years after the Big Bang. Also, this venerable elder has 4 times more mass in stars than our Milky Way does today. This strange discovery challenges what we know about galaxy formation and the nature of dark matter. Everything we know tells us that galaxies shouldn't have formed so early. There shouldn't have been enough dark matter for that, but here we are. So, perhaps our models need some revision. There was an incredible astronomical event called AT 2021 LWX, which is also called Scary Barbie. It was an unbelievably bright burst of energy that happened on April 13, 2021. It's one of the most energetic space events ever observed. No galaxies or quasars were nearby. So what in the world happened? At first, astronomers thought that it was caused by a supermassive black hole pulling in a massive star. But after some studying, They think it's probably because a giant black hole had some crazy dinner. It probably ate a large amount of gas, possibly a giant molecular cloud. The Titanic black hole in question is between 100 million and a billion times the mass of the Sun. This is one of the most massive known and active black holes. Astronomers found the oldest strand of the cosmic web ever seen. The cosmic web is what we call a huge structure of the universe that's made of interconnected filaments of galaxies and dark matter. They're like a framework for galaxies and other structures, playing a crucial role in their formation. The filament we're talking about is made up of 10 closely packed galaxies. It's unimaginably huge, stretching over 3 million light-years. And it looks like the newly discovered strand is very ancient. It occurred only 830 million years after the Big Bang. It's probably anchored by a luminous quasar. This discovery makes us question how exactly galaxies are formed and what exactly happened to our universe after the Big Bang.
The Hubble Space Telescope was put into a low Earth orbit in 1990. If you think about it, it has had over 30 years of experience looking at various space objects. It was named after astronomer Edwin Hubble and was built by NASA. It is also part of a group of devices called NASA's Great Observatories, along with the Compton Gamma Ray Observatory, the Chandra X-ray Observatory, and the Spitzer Space Telescope. The Hubble Space Telescope was built to explore the universe and answer some of its biggest questions, such as how galaxies form and evolve and how the universe itself has changed over time. The telescope has made many important discoveries, including providing evidence of the existence of dark matter and helping to determine the rate of expansion of the universe. One of the most famous images taken by the Hubble Space Telescope is the Pillars of Creation. It's a photo of a region of the Eagle Nebula where new stars are born. The photo, which was taken in 1995, shows massive pillars of gas and dust towering above the nebula. It has become one of the most iconic images of the universe. The Hubble Space Telescope continues to operate and make important scientific discoveries despite some initial technical difficulties. In 1993, a problem in the telescope's main mirror was discovered, which affected its ability to focus light properly. A repair mission was sent to the telescope in 1994 to fix the problem, and since then, the telescope has continued to work perfectly. One of the most interesting discoveries made by this amazing telescope is actually pretty recent. A report based on the data from the Hubble Space Telescope shows that there is a faint glow in space around the solar system that cannot be explained by anything we know to exist. Because they have yet to figure out the source, astronomers call this mysterious glow ghost light. We do know that this light is not coming from the stars or galaxies near the solar system, nor is it coming from dust on the solar system's plane. The researchers are not sure what the source of the light is, but they think it might be tiny particles of dust and ice left by comets. But it's only a theory that has not been confirmed. When we study the universe, we often find bright things like planets, stars, and galaxies. But from time to time, we discover some light coming from places where we didn't expect to see it, like from between planets. This light may be coming from deep within our solar system, and it may be a new phenomenon that hasn't been studied before. In other words, there may be something at the center of our galaxy that produces a lot of light. Spacecraft Voyager. I also captured images showing a lot of light coming from the edge of our solar system. How come we haven't noticed this until now? Well, because most of the light in pictures taken by the Hubble telescope comes from things close to Earth. But people usually ignore this light because they're interested in things like stars and galaxies that are farther away. We've never actually looked closely at the amount of light in the universe and where it comes from. Scientists have been using the Hubble to find faint galaxies that may have been missed before and which may be the source of this dim glow. They found that there are not enough such galaxies to account for extra light in the sky. It's not a lot of light though. It is like the glow from 10 fireflies, but it doesn't make it less important. It shows that we may be missing something. Let's look at some other important discoveries we've made with the help of Hubble, like dark matter, which we can't see but know is there because of its effect on gravity. It makes up for about 23% of the universe. By looking at how it affects light, the Hubble telescope helped make 3D maps of where dark matter is. These maps showed that dark matter seems to be getting clumpier over time, which means it behaves very similarly to how gravity does. The Hubble telescope also discovered 2 new moons around Pluto, named Nix and Hydra, and studied the dwarf planet's changing surface. Additionally, it's found the mass of planet Eris, which is larger than Pluto. This helped scientists realize there may be similar objects in the Kuiper Belt, a region outside our solar system. This led to Pluto being reclassified as a dwarf planet. Further observations of these distant objects could help us understand the evolution of our solar system. Gamma-ray bursts are the most powerful explosions in the universe, and for a long time, no one knew where they had been coming from. Hubble helped us find out that these bursts happened in galaxies, producing a lot of stars and having few heavy elements. This suggests that gamma-ray bursts happen when big stars collapse into black holes. These galaxies have lots of big stars that fall apart quickly, and the stars there don't have much heavy stuff, so they can turn into black holes. In 1994, the Shoemaker-Levy 9 comet collided with Jupiter. Hubble captured the whole event in detail, like a resourceful journalist. The impact broke the comet into a lot of small pieces, which resulted in 21 other visible collisions. The largest impact created a fireball and a dark spot on Jupiter's surface. Hubble's observations not only sparked public interest in cosmic impacts, but also provided new insights into Jupiter's atmosphere. To move forward with our list of discoveries made by the Hubble telescope, we also need to talk about black holes. They are points in space where gravity has so much force that even light cannot escape it. The gravity becomes so strong that matter gets squeezed into a very small space. We know that this can happen when a star, like the Sun, nears the end of its life. At the beginning of its life, a star's hydrogen ignites in its dense, hot core. Because of gravity, it tries to draw its own mass into a tiny point. As long as it has the energy generated by the hydrogen fusion, it also pushes outward. If we look at it this way, the life of a star depends on a delicate balance between these forces, and it can last millions or even billions of years. Once that energy is exhausted, the only force remaining is that of gravity. So, some stars become black holes. Since light itself cannot escape their pull, we can't visualize black holes. For the human eye, they are invisible. We need special tools and unique telescopes to help us point them out in the universe. Hubble found that most galaxies with a central bulge of stars likely have supermassive black holes. It has also noticed a strong connection between the sizes of these black holes and their host galaxies, which might help us understand how the universe has changed over time. Then, what is a supermassive black hole, you might ask? Go ahead, ask it. It is a very large black hole that is typically found at the center of a galaxy. It is millions or even billions of times more massive than the Sun. These black holes are so powerful that they can swallow stars and even entire galaxies. Scientists are still exploring these mysterious objects, but they believe that they play a crucial role in the formation and evolution of galaxies. Before Hubble, we didn't really know how old the universe was. It often led to weird paradoxes, like the one where stars discovered by astronomers were older than the universe itself. But by figuring out the approximate rate at which the universe is expanding, Hubble helped us narrow down its age. About 13.75 billion years. Trying to figure out the exact age of the universe is an important question. That's because most astronomers think that the universe has not existed forever, but appeared in one really hot and dense fireball called the Big Bang. I wasn't around then,